यस, गुड मॉर्निंग स्टूडेंट्स। देखिए हम अभी बात कर रहे थे रिलेटेड टू द मोमेंट ऑफ इनर्शिया। मोमेंट ऑफ इनर्शिया से रिलेटेड हमने प्रॉब्लम्स भी डिस्कस कर ली है। यस, द नेक्स्ट थिंग दैट वी विल डिस्कस दैट इज कॉल्ड टॉर्क। देखो टॉर्क क्या है। टॉर्क इज बेसिकली you know कि in the translational motion the force will act on a body due to which it start accelerating. The same thing is the role of the torque in the rotational motion. Torque is the moment of force and it provides rotational effect to a body about an axis. This is the role of torque. Torque is represented by the symbol that is tau. देखो हम टॉर्क डिफाइन कैसे करेंगे? हाउ द टॉर्क इज डिफाइंड फॉर द एनी फोर्स। किसी फोर्स के लिए हम टॉर्क को डिफाइन कैसे करेंगे? सबसे पहले आई एम टेकिंग कि लेट्स सपोज दिस इज द पॉइंट O, दिस इज द पॉइंट P, दिस इज द वेक्टर joining O to P which is the R vector. And the force is acting in this direction. Let's suppose here you will take it is in this direction. The force is acting in this direction. Now, and the angle between the point, this is theta. So the torque is depending on the force acting on a point and about which point you want to write the torque due to that force. Like here, force torque due to force F about a point O due to force F acting at P about a point O is defined as, that is tau vector is, that is R vector cross F vector, R cross F. If you will write the magnitude of the torque only, the magnitude is R into F into sine theta. This is the magnitude of this. That is R into F into sine theta. If you will look at there, you can easily see. देखो इसको लोग कई बार ऐसे भी डिफाइन करते हैं. If you extend this force, इस फोर्स को थोड़ा सा एक्सटेंड कर दो आप. Now drop a perpendicular from there. This is the perpendicular I have drawn. If this is angle theta, this is also theta. This is the hypotenuse of this triangle. So how much is this? Isko if I am taking A. So what is A? If this side length is OP is R, this is R. So this will come out to be R sin theta. So if you will see कि tau is equal to, that is R sin theta into F. तो लोग इसको ऐसे बोलते हैं कि R sin theta is called, that is what? That is OP into F. OA. What is OA? इसको लोग लीवर आर्म बोल देते हैं. That is the perpendicular distance of line of action of force about या from O. that is this, into F. This perpendicular distance is also called lever arm. So torque is also written as, the magnitude is lever arm into F. This is also written as torque of any force about any point. That is the torque of a force about any point. So this is also written as R cross F, that is R into F into sin theta. It is written as R sin theta into F, that is called lever arm. That is called lever arm. Clear? So this is the torque. Same, it is defined about an axis. Now one more thing, it is a way to calculate its magnitude. How the direction of torque is calculated. That is the direction of torque. Direction of torque is calculated with the help of right hand thumb rule. So it is calculated with the help of right hand thumb rule. That is the thing. Because we know what is torque. R cross F. Again, the thing is that you place your fingers in the direction of R vector. That is a vector, yeah, position vector of any point about the point we are writing the torque. That is R cross F. F is the force acting on that point. This is the torque. Now the next, that is the torque about an axis. For a body hinged about an axis, torque is provided by a force if force is not passing through the axis. It is not parallel to axis. It is having component in the plane of body and is acting at some distance. from axis. Because I want to say this thing, if this is the, let's suppose, the body. And this is the axis about which it is rotating. Let's suppose. It is rotating about that axis with some omega. So, whenever the force, how the force will provide the torque? Dekho, if the force component is parallel to the axis, then it will not provide any torque. If this is parallel to the axis, then how it will provide the torque? Because it cannot move about it. If the component force is passing through this, let's suppose it is passing through this, then also it will not provide torque. It will provide torque if and all it is in its plane. Now this is the force. This is in its plane, then it is provides some torque about the given axis. About the given axis. So it means component of the force which is lying in the plane of the body and having some distance from the axis, it will provide some torque. Is it right? That is the thing. And again the torque is again that. The torque is again here also. That is the lever arm into F. The magnitude. And direction of torque can be clockwise or it can be anti-clockwise. It can be clockwise or it can be anti-clockwise, that one again. Right? Next is couple. Two equal and opposite forces acting at opposite corners of a body behaves as couple. This is a body, let's suppose. And the two forces are acting in this direction. One of the forces is acting like this. Another is acting like this. This is the line joining to them. So this is acting as a couple. And if the distance is r, तो you can say the torque is directly what? That is the lever arm. दोनों की torque same direction में है. If the both torques are in same direction, the total torque is 2 into due to each, and due to each it is F into R. So it is, you can say it is force into how much is the distance between these two 2R. That is distance between forces acts as couple. Right? तो बेसिकली इट्स जस्ट अ न्यू टर्म कि अगर दो इक्वल और अपोजिट फोर्सेस किसी अपोजिट कॉर्नर्स पे बॉडी पैक करती है तो उनके जो कॉम्बिनेशन है हम उसको कपल बोल देते हैं. दैट इज कॉल्ड कपल बिकॉज इट इज प्रोवाइडिंग द टॉर्क दैट इज इक्वल एंड अपोजिट इन अपोजिट डायरेक्शंस एंड दिस इज द थिंग. राइट? Next, equilibrium of a body. A body is said to be in equilibrium if net force acting on a body is 0 as well as net torque acting on a body is also 0. Means the body is said to be in equilibrium if it is in translational equilibrium as well as in rotational equilibrium. So you can say a body is in equilibrium if it is in rotational as well as translational equilibrium. If it is in rotational as well as in translational equilibrium, then the body is said to be in equilibrium, right? So it is torque net about this is 0 and also the net force acting on a body is also 0. Then it is said to be in equilibrium. Is it clear? So that time it is called in equilibrium. Just write down the problem. Two child of masses 10 kg and 15 kg are sitting at the ends of at the ends of 5-meter long seesaw. Full stop. Calculate position of fulcrum from 15 kg mass if seesaw is horizontal. Means this is the thing. There is a seesaw plank and you can see कि there are two masses, that is of 15-year child, this is of 10 kg and there is another child of 15 kg. This is a child of 15 kg and the length of this plank is 5 meter. तो क्वेश्चन पूछेंगे कि फलक्रम कहां पे प्लेस करें सो दैट इट विल रिमेन एट रेस्ट, इट विल रिमेन एट हॉरिजॉन्टल फ्रॉम 15 के चाइल्ड. मान लो 15 के से हम एक्स पे रखते हैं द हिज पोजीशन ऑफ द फलक्रम. इफ इट इज पोजीशन एक्स देन फ्रॉम देयर इट इज 15 माइनस एक्स, right? If we will observe it, there is mg is acting there, that is 15g, and here it is equal to acting 10g, and corresponding to that the normal reaction is acting in upward direction, Fn. Now if we look at the equilibrium of this body, अगर हम देखें कि it is in equilibrium, अगर ये चीज इक्विलिब्रियम में है तो यू कैन डायरेक्टली से फॉर इक्विलिब्रियम अगर मैं बात करूं ट्रांसलेशनल इक्विलिब्रियम की, if it is in translational equilibrium, so you can say the vertical forces are 0. मतलब 10g plus 15g, it is equal to Fn. That is the value of Fn. But if we look at the rotational equilibrium, because it is also not rotating, एक एक्सिस या एक पॉइंट के अबाउट ये रोटेट भी नहीं कर रही है. अगर रोटेट ना करे तो मैं क्या बोल सकता हूं कि नेट टॉर्क इज 0. दैट इज द रोटेशनल इक्विलिब्रियम. That is tau net is 0. Now net torque you can write about any point. You can write about any point the net torque. मान लो this is a point O. If you will write about this point, so this Fn will not give any torque because it is passing through this point. So torque is given by this. Now this 10g will provide the torque that is in anti-clockwise direction, and 15g will provide the torque that is in clockwise direction. So you can say if this is in equilibrium, rotational torque is 0. So 10g will provide positive and this will provide negative. 10g की torque कितनी होगी? 10g into lever arm. What is the perpendicular distance? About O we are writing. That is about O. That is 10g और lever arm कितना होगा? Perpendicular distance 15 minus x. Because अगर मैं इसको extend करूँ, this is a 15 lever arm. That is 15 minus x. This is equal to 15g into x. If you will calculate it, you will get the value that is equal to 25g into x. It is equal to 10g into 15. So what is x? That will come out to be 10 into 15 divided by 25. That is 6 meter. That will come out to be 3 into 2. If you will solve it, this is not 15 minus x. That's wrong. I have taken. This is 5 minus x. Sorry. The length is 5 minus x. If this is 5 minus x, this is also 5 minus x. If this is 5 minus x, that will become 50g and that is 25g. That will come out to be 2 meter. That will come out to be 2 meter. This is the thing, right? Yes, the next one. A rod of length L and mass M is inclined to wall and horizontal surface. Making an angle theta with horizontal. As shown. if friction coefficient between surface and rod is mu, then calculate normal reactions between rod and surfaces, comma, friction if it is not sliding. This is the thing. This is the rod. Right? Having the length L and mass M. There is a normal reaction provided at this point. This is Fn1. There is normal reaction is provided at this point, Fn2. Right? And Mg is acting in downward direction. And if he is having the tendency to slip in this direction, the friction will act in this direction. Static friction. You can consider this is the point A. This is the point B. And the next thing is this angle is theta. This angle is theta. It is given. And the length of the rod is L. The length of the rod is L. Right? So we have to calculate the value of the normal reactions and this. If it is in not sliding. Not sliding matlab it is in equilibrium. Rod is in equilibrium. If it is in equilibrium, that is in translational equilibrium as well as in rotational equilibrium. So for the translational equilibrium, we can say net force in horizontal direction as well as in vertical direction is 0. So what is the net force in vertical direction? That is mg and Fn2. So mg should be equal to Fn2. And what is in this direction? That is Fn1 and friction. These are the two equations for the translational equilibrium. Right? And for the rotational equilibrium, we can say कि the net torque is 0. So net torque is 0, and if it is in rotational equilibrium, the net torque will be 0 about each and every point of the body. So we will write the torque about that point from where the other forces are passing, so that we have not to consider the torque for those forces. Like if you take the point B point पे अगर हम लिखे तो there is no need to write the torque of these two, but we have to write the torque of mg and Fn1. mg and Fn1 we have to write the torque at these points. So if we write the torque, so we can say torque net about B. So mg, this Fn1 will given the torque in this direction. That is, you can say the Fn1 is giving the torque in the, that is, you can say in the direction which is called the direction of, that is a clockwise direction. and this mg is giving the torque that is in anti-clockwise direction. The torque by mg is equal to torque of Fn in magnitude, तभी ये उसमें रह पाएगी. Now what is the torque given by mg? देखो mg is acting in this direction, so write down this lever arm. This is the lever arm for mg, and Fn1 is acting in this direction, so this is the lever arm for this. Yeah, is it right? So if we write this thing, this is L by 2, this is L by 2 cos theta, so this is L by 2 cos theta. Similarly, this is L, this is theta, this is also theta. If this is L, so this is L sin theta. The whole length of the road is L. The whole length of the road is L. Right? So we can write torque of mg into L by 2 cos theta. And what is the torque of Fn1? Fn1 की torque क्या है? That is Fn1 into L sin theta. This L and L will cancel out. And what is Fn1? Fn1 is equal to this, and mg is equal to Fn2. And this is what? Friction. Mu into Fn2. Fn1. By solving the three equations, we can get easily the value of, that is the value of the Fn1, Fn2, and the value of other thing, that is the friction. So by solving, we get values of Fn1, Fn2, and theta, and friction. So we can calculate the values of those things by solving it. Is it clear? लिखे इसको. हाँ जी, नेक्स्ट प्रॉब्लम देखेंगे. So next, an inclined plane of inclination angle (45° is at rest with a wall as shown. A rod of mass m and length L is placed perpendicular to incline in support with wall. Calculate minimum coefficient of friction between the rod and the incline if it not slips. This is the thing. हमारे पास ये चीज है, there is an incline there at an angle of 45 degree, and this is this. Now the rod is placed perpendicular to it. This is the rod placed perpendicular to it. Right. So we have to calculate if it is not slipping, what is the value of all these things. This is the thing. So if you make it more clear, it is like this. Make it more clear like this. So देखो यहाँ पर हमारे पास क्या होगा, if it is not slipping, there is a normal action provided in this direction Fn1, there is it is provided in this direction Fn2, right, and it has a tendency to slip in downward direction, so friction will act in upward direction. The mg is acting in downward direction. Is it clear? So mg will act in this direction, that is the thing कि mg यहाँ लग रहा है. So these are the forces acting on it if rod doesn't slip. Then it is in equilibrium. अगर ये equilibrium में है तो rotational equilibrium as well as translational equilibrium. If I consider this is the point A, this is the point B. Right, तो मैं क्या कर सकता हूँ? तो फर्स्ट ऑफ ऑल ट्रांसलेशनल इक्विलिब्रियम. Translational equilibrium. How many forces are in horizontal direction? These are in vertical horizontal, but if we take the component of this F, it has one component in this direction, another component is there. If this is F, this you can write, this is 45, this is F by root 2, this is also F by root 2. Right? So if we see how many forces are in horizontal direction, there is one for this, there is one for this. If this is acting in this direction and it is in this direction, so it has a tendency, if it is in translational equilibrium. If it is in translational equilibrium, तो it means it will slide in the downward direction. तभी इसको वो कर सकता है, बैलेंस कर सकता है फ्रिक्शन. तो it means the friction will act in a opposite direction here. क्योंकि अगर हम देखें तो Fn1 और F by root 2 का जो कंपोनेंट्स आ रहे हैं वो सेम डायरेक्शन में आ रहे हैं, बट इफ वी वांट टू बैलेंस इट, so the friction will act in downward direction. This friction direction will changes. The friction that is acting, it is acting in downward direction. अगर फ्रिक्शन नीचे रहेगा, इट मींस की टेंडेंसी उल्टी है फिसलने की. तो इसके ऊपर दो कंपोनेंट आएंगे F by root 2 के अगेन. एक कंपोनेंट तो हमारा इधर निकलाएगा और एक कंपोनेंट हमारा नीचे निकलाएगा F by root 2. This is also F by root 2. तो what is in translational equilibrium हम क्या लिख सकते हैं? Now I can write Fn1 is equal to F by root 2 And in translational equilibrium in vertical direction, we can write mg is downward, the friction is downward, Fn2 is upward. So mg plus friction is downward, F by root 2, it is equal to Fn2. And we know friction is mu into Fn2. And what is in rotational equilibrium? The friction in this is passing from this point. So you can write the torque of these two. अगर इन दोनों की टॉर्क लिखने जाएंगे, दिस इज एल. अगर इन दोनों की टॉर्क लिखने जाएंगे तो वी विल नीड, दिस इज द पॉइंट, दिस इज द पॉइंट, तो दिस इज द लाइन ऑफ एक्शन, दिस इज अबाउट बी, इफ आई राइट अबाउट बी. इफ वी विल राइट द टॉर्क अबाउट पॉइंट बी, बी के अबाउट लिखो तो ये इस डायरेक्शन लग रहा है, तो बी के अबाउट जब हम लिखने जाएंगे तो दिस इज द रीजन, दिस इज एल, तो हाउ मच इज दिस, दिस इज एंगल इज 45, 45, this is 45, 90, this is 45, this is 45, this is L sin 45, this lever arm will become, this क्या आ जाएगा L sin 40, L by root 2, और ये mg लग रहा है, this is L by 2, अगर mg ये लग रहा है तो इसकी lever arm क्या आएगी, this is the lever arm of the mg, यहाँ पर आएगा, this is the lever arm, ये L by 2 है, these angles are 45, if these angles are 45, so it means again it will come out to be L by 2 root 2, L by root 2, so we can say the torque is provided only by the torque of mg is equal to torque of Fn2 Fn1. What is the torque gained by Fn1? That is Fn1 into uski lever arm will become L by root 2. And what is for mg? Into lever arm is L by 2 into 1 by root 2. This is cancel out. Mg by 2 is Fn1. 2 is equal to Fn1. Solve the three equations, you will get the value of mu, minimum coefficient. By solving, you will get the value of mu, because here F is also is equal to what? Mu into Fn2. This is the thing. Is it clear to all of you? Now the next is Newton's law in rotational mechanics. In rotation. देखो, according to Newton's law, about any axis, torque is equal to rate of change of angular momentum. That is dl by dt. If we write it in more appropriate way, the torque is written as basically I into alpha. You don't know the value of L. L is basically the angular momentum, but it will be introduced somehow later. The I is basically the moment of inertia. And alpha is called angular acceleration. That is the moment of inertia, and alpha is called what? Alpha is the angular acceleration there, right? So we can use this thing for the Newton's law in rotation. That is a constraint motion of pulley. What is this? If pulley used is not ideal, but having some mass and even string is not slipping over it, that is, pulley is doing rotation. Then we need to write equation of rotational for pulley to solve problems. Let's suppose you are taking key, this is the system. This is a pulley connected to it. Here there are two masses, that is n kg, and this is a mass of 2m. But this time the pulley that is connected, it is not fixed. It can rotate. Like here we can easily see this will move with acceleration in this direction, it will move in acceleration with this direction. So then this pulley will also rotate. It will also rotate. If about its axis, let mass of pulley is equal to m. Radius of pulley r. Moment of inertia of pulley is equal to I. So we can write what thing? जैसे अगर ये rotate कर रहा है, now this time tension is also not equal. But here it is mg is acting. Here T is acting, T1 you can take. If here it is T1, so it is also T1. Here it is T2, so it is T2. Here it is acting T2, and here it is acting 2mg. So we will observe in this problem there are four variables, that is T1, T2, A and alpha. So we require the four equations. Now how the four equations? Look at the translational equation of this m1g. m1 के लिए लिख सकते हैं, तो we can write कि m1g minus T1 या T1 minus mg is equal to what? M into A. This is moving in this direction. It is moving m2 के लिए 2m के लिए लिख दो. उसके लिए क्या लिख सकते हैं? 2mg minus T2 is equal to 2m into A. And if we write for pulley, pulley के लिए क्या लिख सकते हैं? Pulley is also rotating. Both T1 and T2 are providing the torque. T2 is providing the torque, that is basically in which direction? That is in clockwise direction. T1 is providing anti-clockwise torque. So you can write T2 into R minus T1 into R, it is I into alpha. And fourth thing we can write for relation between rotation in this, that is A is equal to R alpha. So there are 4 variables and the 4 equation. Now you can solve such type of constraint problem of the pulley when it is not massless pulley, or you can say when there is a friction is present in between these. Right, means the string is not slipping on the pulley. If it is not slipping, then you can write these equations for the pulley and you can easily solve such type of problems. Is it right? So you have to discuss it, and this is the thing, write it.